have gathered here to discuss a case study discussion about controllability and observability in modern industrial process control system. So we have discussed the concept of controllability and observability in our class. Okay? You know about the theoretical concept, and now you relate and do the case study discussion about how it will be facing challenges and how it will be working in the industrial side control systems. Okay?
Let me give an introduction about controllability and observability. Controllability is the ability of the control system to move the state of the system from any initial state to a desired final stage within a finite time period. And observability is the ability of the system to measure the internal characteristics used to the external parameters. So why do these things matter? Without controllability, we cannot determine the stability and performance of the system. And without observability, we cannot design a feedback loop. We can also use Kalman and Dilbert's method to measure these things mathematically.
Okay, as Abhishek has said, the overview of observability and controllability. Now, let me focus on the application of observability and controllability in industrial applications. When we speak about the applications in industrial of control systems, we can take an example of distillation columns. Distillation column is a refinery method used in petroleum industries and other oil refining industries. We use large columns to refine oils from the waste residues. Here there are some key components which involves control systems, control system methods, logics, etc. The key components are heat preheater, then sensors such as temperature sensor and pressure sensors, reboiler, distillation column, and top bottom collector chambers. These are used to refine oils in distillation columns. The main control goal is to purify the oils which are in impure form. This can be also controls the temperature and pressure of the oil in the chamber. These are controlled by the sensors and actuators which are installed in the components.
Now we can focus on controllability. First, what is controllability? Controllability means the input we give have to be controlled and it should be in a stable manner, and then it could be resolved. Right? For controllability, we are checking. We use matrix mirror. Where for 3 into 3 matrix, we use A, AB, and A square B in formula, and then we do it. And imagine a car. If a car's steering is not turned and the wheel is not turning, the wheel is not turning to the right over, then there's no usage with the steering. So we must the controllability must be more capable manner. So that we are comparing with this normal controllability. The system should be of effective control. Then only the feedback can be given in a proper manner. So that if the controllability is not in a stable manner, then the system's pole placement and cannot be what we desire. The pole it should be according to what the control is given. So that the controllability should be equal to the state matrix. According to the state matrix and what we have equal to this.
Okay, observability. What is observability? Is in the sense, if a system is observable for any possible sequence of state and control vectors, the current state can be determined in a finite time using the outputs. So, if we take an example for we are traveling in a car, the speed should be measured by the speedometers. So if the speed sensor functions are properly working, in a sense, we can determine the speed using the speedometer. If the speed sensor is not working properly or it is damaged, there is no way of measuring the speed. So we need an observability system in that car. Okay, why observability is important? In the sense, for state estimation. In many systems, internal state like temperature, etc., can be determined, and observability can infer from available output. Next one is monitoring and fault detection. So fault detection and abnormalities in the system can be found by these observabilities. This observability can be found by Kalman's rank condition, which is rank of C transpose, C transpose, A transpose, and A square transpose, C transpose, and it goes on.
And finally, we are seeing the solutions and the model problems. In the fundamental concept of the controllability observability, we in the system is able to the manipulated and then understood. When we are seeing the modern system, especially they have the complex one, like in the software debugging and then another distributed system we are seeing. In the challenges is arise ensuring like properties in the increasing the complexity of the dynamic condition. We have seen the challenges they got the increase of the complexity and the dynamic environment, difficulty to the tracing vehicles, and the scalability and performance. And finally, the lack of the real-time understanding. In the modern solution, we have these are they are observability tools, distributed tracing, and the advanced monitoring, logs and metrics, AIP observabilities, and the automatic debugging.
So theoretically, we have seen this concept of controllability and observability in our class. So by this discussion, you know how this will be useful in the industrial, as well as what are the challenges we have faced by using the concept of controllability and observability. So I hope you understand this concept. Thank you for participating in the discussion. Thank you.
Thank you.